Hello, kids. This is your teacher JR. So our lesson for today is about describing experimental and theoretical probability. Okay. Before we start with our lesson, let us first uh, see our learning objectives. Okay. Number one, perform experiment and record outcomes. Number two, make listing and diagrams of outcomes and tell the number of favorable outcomes and chances using this listing and diagram. So learning objectives number three, make simple prediction of events based on the result of experiments. Okay, so what is probability? So probability is a number from 0 to 1 that tells you how likely something is to happen. So we have two types of probability. So number one, we have the experimental probability. Number two is the theoretical probability. So let's discuss the difference between experimental and theoretical probability. Experimental probability. So we can say that it is an experimental probability when you do the experiment yourself. Okay. Then we have also a formula in finding the probability of an event. Okay, so this is the formula, which is the number of times events occur divided by the total number of trials. So this is how you get the probability in experimental probability. Next, we have the theoretical probability. So theoretical probability, it's just what should be or it's what should happen in an ideal situation. Okay, it depends on the variables or it depends on the given data. Okay, then we also have the probability formula for theoretical probability, which is number of favorable outcome divided by the total number of possible outcome. Okay, then this one, how can you tell which is experimental and which is theoretical probability? So experimental probability, this one is an example of an experimental probability. For example, you toss a coin 10 times and recorded a head 3 times. This is the result, okay? So when toss a coin, 3 times, it comes out head, then 7 times, it comes out tail, okay? So this one, just like what you saw on the definition of experimental probability when you do the experiment. This one, you do it yourself. You toss a coin 10 times and then you recorded the result. So what if I'm going to ask you, what is the probability of an event or getting a head as the result of the event? Okay, so this again, our formula is about number of times event occurs total divided by the total number of trials. So we have, I did ask you the total number, this one, the probability of getting ahead. So this one, again, the number of times of event occurs. So we have three times comes out head. So we have 3. This is the number of times the event occurs because I just asked you the probability of getting head. Then total number of trials, total number of trials. Okay, so the number of trials is 10 times because you toss a coin 10 times. So you're gonna write here 10. Okay, so this is the probability of getting ahead. Okay, so we have 310. We could use fraction in probability. We could also use percent. Okay, so 310, when you divide it, it should be 0.3. Okay, 3 divided by 10, you'll have 0.3. Now, we were going to move the decimal point to change it into a percent. So we're going to move twice. Okay, this is your decimal point. This is the original position of your decimal point. So move it twice, and then there's space here. So we're gonna put 0. So it would be 30, and then put a percent sign. So we could also use the probability of an event, which is, or the result will be 30%. 310 is the same as 30%. Okay, So the probability of getting ahead is 30% or 310. Okay. So this is the result. Next, getting a tail. So tail, it says here that the result, we have 7 times the tail comes out. Okay, same formula. This is the number of times the event occurs, which is the tail, 7. And then the total number of trials is 10. So it should be 710. Or if you want, you could change it again into percent. We could represent it into a percent. So first, you could just simply divide this, make it into a decimal. 7 divided by 10, that would be 0.7. Okay, move the decimal point twice to the right, it will become 70%. Okay, so the probability of getting ahead as a result is what do you call this? 0.7 or 7/10 or 70%. Okay, so that is how we get the probability in the experimental probability. Okay. Next, we have the theoretical probability. So this one, theoretical probability, we are using only theory. Okay. We are just basing our answer based on the variables or the given data. For example, toss a coin and getting ahead or a tail is 1 out of 2 sides, right? This one, we only use the theory because we know that a coin only has 2 sides, right? We called it head and tail. So if I'm going to ask you what is the probability of getting ahead, you'll answer. So this is the formula, number of favorable outcome over total number of possible outcomes. So if I'm going to ask you what is the probability of getting ahead, that is your favorable outcome. So there is one possible outcome of ahead because we only have 2 sides of coin, the head and the tail. So 1 is your favorable outcome. So total number of outcome in when you toss a coin, of course, it would be 2. That would be the possible outcome, head and tail. So the denominator would be 2. So 1/2, or you could also again represent it into a percent if you want. 1/2 is the same as, in a percent, you divide 1 divided by 2, or just like what is 1/2 of 100? So 1/2 of 100 is 50%. Okay? So this one is a 50% chance of getting ahead. Okay? Next one, we have, of course, we have the tail. So favorable outcome, number of favorable outcome when you are being asked about the tail. So that's 1. The number of possible outcome, that's 2. Okay, we have head and tail. So for tail, the probability is also 1/2 or 50%. Okay. Next, identifying the types of probability. So you've learned already what are the types of probability. We have the experimental and the theoretical probability. Again, when you say experimental, you do the experiment. Okay, theoretical, you can use the theory or the variables or the given data. Okay, you could just simply guess the answer based on the given data. Okay, so this is the one way of doing probability using a marbles. Okay, for example, here a bag contains 3 red marbles and 3 blue marbles. Okay, so what if I'm going to ask you what is the probability of an event that you will have a blue or a red as a result? So this one is the probability of getting a red. So we have here 3 red marbles. This is the favorable outcomes. Okay, then we have also 3 blue marbles. Okay, so here we have 3. Okay, 3, 6, because we have 6 marbles in the bag. 3 red, 3 blue. You are being asked what is the probability of getting a red, so that is our favorable outcome. So we have three red marbles, so 3 will be the numerator. So because it is expressed as a fraction, so as we know, if we are dealing with fraction, we could also simplify it, right? We have learned that when we are dealing with fraction, we should always express our answer in the simplest form. So 3/6 could be simplified as 1/2. Okay? Now, what if I'm going to ask you about the blue? So what is the probability of getting a blue marbles? Okay? This one, wait. So the probability of getting blue marbles, so the favorable outcome is again 3. Okay? Because we have 3 marbles. And then the total number of outcomes is 6. Okay? So this one could be simplified again with 1/2. So what kind of probability do you think this one? Okay? So this one is the so-called theoretical probability, because you are just basing your answer on the theory or on the given data, okay, which is the 3 marbles and 3 blue marbles. You didn't do any experiment, okay? So this one is the theoretical probability. The result is based on the possible outcome. Okay, next. Let me clear that up. So identifying the type of probability we have here. Okay, so trials. Okay, trials of getting the marbles in the bag. Okay, you draw a marble out of the bag, record the color, and replace the marble. After 6 draws, you record two red marbles. Okay, so meaning from its sentence, you draw a marble out of the bag, meaning you do it yourself. From that sentence, we could easily say that this one is an experimental probability because you do it yourself. You do the experiment, okay? So probability of getting a red, we have 2, recorded 2 outcome of red. Then we have 6 possible outcome. So the probability of red is 2/6. Then simplify. 2/6 can be simplified as 1/3, okay? So this one is the experimental probability. The result is found by repeating an experiment. Okay, you do it yourself. Next, contrast experimental and theoretical. So when we say experimental, it is the result of an experiment. Theoretical, it is what is expected to happen. Okay? Now, we could also describe the probability. Okay? As you can see, we have here a number line. Okay? So probabilities can be shown on a probability scale, which ranges from 1, which is certain to happen, to 0, meaning impossible to happen. Okay? For example here. Okay, look at this data. So 0% is the one, this one, 0% is, or 0 is impossible to happen. As an example, let's say I have 10 black marbles in the bag. Then I'm going to ask you, what is the probability of getting a white marble? So of course, it is impossible because there's no white marble in the bag. I told you that I have 10 black marbles in the bag, right? So, and then I'm going to ask you, what is the probability of getting a white? Of course, it is 0% or impossible because there is no even a single marble that is white in the bag. Okay? The next one is the unlikely. So unlikely, it is less than, as you can see, we have here the 50%. So meaning, unlikely is in between the 0% to 50%. So it is less than 50%, but not 0%. Okay? Meaning 1 to 49%. You could just easily say it is unlikely when it is less than half of the given data. Again, let's say, for example, uh, let's use again the marbles, okay? So for example, I gave you an example, which is 5 red marbles, okay? Then we have 2 blue marbles, okay? And then I'm gonna ask you, what is the probability of getting a blue marbles? So it is the so-called unlikely. By describing it, you are not gonna give the probability, you are just describing the probability, okay? So the answer is not a fraction, okay? You are just describing the probability. So this one, as you can see, we only have 2 blue marbles, and then we have 5 red marbles. Then the probability, or describing the probability of getting a blue marbles, is unlikely, because you have a lesser number of blue marbles than red marbles. Okay, so you have a less chance of getting a blue marble when you pick a marble from the bag without looking. Okay, next next is 50%, or the so-called even. Okay, the best example of this is when you toss a coin, just like what we had on the previous example. Coin has only 2 sides, the head and the tail, so that is 50-50 or 50%, or even. So meaning head and a tail has an even chance to come out as the result. Okay, next, the word likely. Okay, so let's use this again, same example, 5 red marbles, 2 blue marbles. So but this time I'm going to ask you the probability, to describe the probability of getting red. So as you can see, there are more red marbles than blue marbles. Okay, so meaning you have a bigger chance of getting a red marbles. So that's why, as you can see here in the number line, so this is 50%. So meaning likely is more than 50%, but less than 100%. It is in the middle of 50 and 100%. So meaning from 51 to 99% should be described as likely. Okay, next we have certain. Okay, the 100%. Okay, so for example, the one that I gave you, 10 black marbles. I put 10 black marbles in the bag. Then I'm gonna ask you, what is, or describe the probability, or what is the probability of getting a black marbles? So of course it is surely 100%, because there's no other color inside the bag. It's only black, right? So surely you'll get a black marbles. Okay, so let's have the next one. Let's clear this up. So let's have the activity on describing the probability. Okay, so for example, describe each probability using the words certain, likely, even, unlikely, or impossible. Okay, for number 1, you are going to breathe air today. So what do you think it is? Is it certain, likely, even, unlikely, or impossible? Yes, this is certain, because all of us are breathing, right? We breathe air every minute, every second. Okay, next example. It is going to rain today. In this case, in number 2, the answer may vary. Okay, why did I say that? Because it depends on the circumstances. For example, if you watch, or if you go outside and you see the sky, that it's very dark, you see dark clouds, so you could say that it is likely to rain today, right? It is based on your observation. But if you go outside and you see that the sky is so clear, so bright, so it is unlikely to rain, right? So it is based on your observation. Next, number 3, you will be in New York tomorrow? So some of you might answer impossible. Yes, because you don't have any plan of going to New York. Some of you might say unlikely because you might go. You have a chance to go there because maybe you have some relatives in New York. Okay, or maybe you will say certain if you really had the plan to go to New York tomorrow. Okay, it depends on the situation. Okay, number 4, you'll be in school in this Saturday. So just like on the example 2, 3, it is also based on the situation. Okay, because some of the school has class during Saturday, especially in college, right? But some school, especially in elementary, we don't have school this Saturday. But some of the teacher is asking from a help from you, right? You might go during Saturday in the school to do something like planting, right? You might help your teacher cleaning the room, or you might uh, help teacher with something to do something. Okay, next, number 5, you will wear a school uniform tomorrow. Okay, just like again the previous example, it depends on the situation. If it is let's say if it is Monday today, and then tomorrow is Tuesday, of course, you'll say certain that I'm going to wear uniform or school uniform tomorrow because there's school tomorrow. Okay? But let's say, for example, today is Friday, then tomorrow is Saturday. So you're going to say it's impossible because during Saturday, we don't have school, right? So again, it is based on the situation. Okay, next example, give the probability of an event as described in each. So this one, a box contains the following number cards. So we have this set of number cards. We have 3, 8, 4, 8, 3, 5, 8, 8, 5, 5. Okay, so find the probability of picking a card with a numeral 4. So we have the favorable outcome. How many 4 do we have here in the set of cards? So we have only 1, right? So these are the total. We have 1 as the favorable outcome. Then how many cards do we have here? This is the total number of outcomes. So we have 10 cards. So the answer is 110. Okay. Next, find the probability of picking a card with numeral 3. So how many 3 do we have here? So let's count. We have 1, 2. So we have only 2 3s, okay? So 2, and then we have 10 as the total outcome. So as we explained earlier, we could also simplify our answer. So 110 could be simplified as 1/5. Okay. Next example, number 3. Find the probability of picking a card with an even number. Okay, before we start, what is even number? So even number are numbers that ends with 0, 2, 4, 6, and 8. So let's count the even number here. 1, 2, 3, 4, 5. So we have 5 even numbers. Okay. So we have 5. So the result should be 5, 10. Right? 5, 10. So the total outcome is 10. So 5, 10, or you could simplify it as 1/2. Okay. Next question. Question number 4. Find the probability of getting an odd number. So odd numbers are, we have odd numbers. We have here 1. So odd numbers are numbers that ends with 1, 3, 5, 7, and 9. So we have also 2, 3, 4, 5. So just like an even number, we have 5 favorable outcomes of an odd number. So we have now 5, 10, okay? Or simplify it into 1/2. Okay, next question, question number 5. So find the probability of picking a card with a number less than 4. So what are those number less than 4? That is, we have 3 only, right? So we have 1, 2. These are the numbers less than 4, meaning 4 is not included because it says less than 4. So 2 possible outcome, and then total outcome is 10. So 210. You could also simplify it again into 1/5. Okay? So is it clear now? So these are the answers. So let's go. Let's proceed. So I think that would be the end of our lesson for today. Thank you and goodbye.